Hello guys, in this new session we will treat conditional branching, if and if else and else. So as you see here as an example, we have a simple program, if true, and we will print 1 if the condition is true, and otherwise we will print 2. So this program, it will has an output print 1, an output 1. So to treat if-else statement, we need to introduce two bytecodes called operation or opjump if false. We will jump over some instruction if the condition is false, and also we have another bytecode called opjump. Also, it will jump to some instruction. So as you see here, we have 2 bytes. These 2 bytes called jump offset. It's an address or how much steps we can go until we find until we point our IP to the instruction. For example, we have this code, and we have loaded true to the stack, and we have opjump if false. So our stack, it has true, so it will not jump, so it will continue, and it will pop, and then it will load constant 1, and also it will print that, and then the VM read opjump, and also it to read the offset, and the offset is 4. Then the VM, it will increment our IP by 4, starting from here, 1 2 3 4, and then by doing that we will offset these instructions. So the question that we need to ask is how to calculate this jump offset. This jump offset means how many instructions we need to jump until we found the instruction that the VM will execute. So this example, if our stack, it has false, it will jump 7 operation, and then it will start executing. For this example, if we have on the stack false, it will jump over this instruction until op, and then it will execute op, and then it will continue. Otherwise, it will continue until it finds jump, and then it will jump to the new instruction, and that is called jump offset. So this jump offset is represented in 2 bytes. So let's see how this bytecode is built step by step. So we have the code, and we emit to our VM true, and also we will emit jump false, and for the first time we have 0 initialized for jump offset, because for now we don't know the end of the block of f. So I will continue doing that. I will load 1, and then I will print, then I will emit jump with 0 initialize, and then from here I know the end of the f block. So I will do back patching to patch the jump offset. So as you see here, we have patched that, and we've add 7. That's mean we have 7 instructions to jump over until we found the instruction that the VM will execute. So I will count 1 2 3 4 5 6 7. So no, okay, I will start from here. Excuse me, I will start from here. 1 2 3 4 5 6 7. So if the condition is false, the VM will jump and will jump in this bytecode at the position 11. So how did we found this number 7? So what we need to do is we have 10 elements, and this we have 11 elements in our code. Then we will subtract the 2 offset, and also we'll subtract 2, and by doing that we will find the number 7. So also for the else block, we've emitted the jump instruction, and offset is 0 initialized. Then we will emit operation of pop. Then we will load to and print that. So here I know that the else block is finished here, so what I need to do is to backpatch that to modify this offset. So what we need to do is we have 14 and the number of instruction is 15, so I will minus that by 9 and minus that by 2, I will get 4. So that's the idea behind if statement. That statement, we have two instructions, jump if false, I will jump over a number of instructions. Number of instruction is the jump offset until we find the new instruction that the VM will execute. So I will continue and then if I saw an instruction jump, I will directly jump by that offset. I will not test what's the state of our stack. In the instruction jump if false, I will need to see what's the state of our stack, and then I will jump under the condition if we have on the stack false. But for the operation jump, it will directly jump that offset. So guys, the question that we need to ask is how do we store the offset into 2 bytes? And the second question we need to answer is how to get the actual offset number. So for this, to answer this question, we will use bitwise operators in C. So we have 2 bytes here, 1 byte and 1 byte is 0 initialize, and let's take an example for 300, number 300. That number 300 is the offset number. So in binary is that in 2 bytes, and what I need to do is to shift that number in binary by 8. I will get these bytes, and then I will do the AND operation with in hex decimal FF, and then I will get the last byte, and the last byte is 1. So what I need to do is to store that one in the first byte of jump offset. So then what I will need to do also, I will get the 300 in binary, and then what I need to do is do the operation and with the number in hex FF, so that will remove all this, the first byte. We remove that byte, and what we will get the last byte, and the last byte in decimal is 44. So that's 44, we'll store it in the second byte. So how do we do the inverse operation? So remember guys, the VM will read these 2 bytes and make a decision, this is the number of the offset, and how we will increment our IP instruction pointer. The VM need to increment the IP, so it will increment the IP by using this jump offset. So the VM need to convert these 2 bytes and get finally the number offset. So what we need to do is to do the invert operation. So I will get the first byte, I will shift it to the left by 8, so I'll get that in binary. Also I will get the 44 and it's binary. I will do the OR operation, and that OR operation is like summing these two binary numbers. So I will get this binary and this binary in decimal is 300. So guys, let's jump to the code and see how we will implement this 2 byte code. So let's jump right to the code. So we will go to our compiler, and as usual I will update our grammar. So in statement I will add another non-terminal if statement, and its definition is like so. It's an if and followed by a left parent and expression, I will call expression, then a right parent and then I will call statement. Why I call statement? Because in if I will do everything we will you can do print statement, expression statement, block, or another if statement if we do some nested if statements. So next we could do else, and that is optionally. You can do else or not. Is the user will decide if it will do else after if or not. So this question mark, it means that it's optional. You can do it or you cannot. So statement. Okay, so let's go and implement that statement. So what I need to do is to go to statement, and after that what I need to do is I will check else if match token if so, if it matches I will call the if statement function. So let's implement this if statement function. So I'll go here and I will do static void if statement, and what we need to do is to consume token left parent. If we don't have that left parent, I will raise an error. Expect left parent after if statement. That's it. And what I need to do is to call expression. Also I need to check the right parent, and now what I need to do, if it's not a right parent, I will raise an error called expect after if condition. This if this expression function, it will treat if condition. So let's continue, and what I need to do, first of all I need to emit jump, and the instruction I will need to emit is up jump if false. This emit function, it will emit to the VM this instruction, and also it will return the index of the first byte of our jump offset. So then I will emit byte up. That is harmful. Why we did emit that pop, I will answer that question here. So I will emit this up because if we have a true condition, so the stack the value on the stack is true, then I will go, the IP will go to the VM, it will treat that jump false by that offset, but the state of our stack is true, so it will not shift the IP with that offset. So I must delete the value from the stack, because it's will not be helpful if the value true stays on the stack. So I will continue to treat the else block. So that's why I emit that pop. So if the condition is false, I will not do pop because I will use it. So I will jump directly to another pop here. Okay, so let's continue. Okay, then we will expect a if block. So I will call statement function to handle it. Statement, and also I need the else offset, and I will emit jump up jump, and after that what I need to do is to backpatch the if offset. So remember, the if offset is the index of the first byte. Like in this example we have 2. So when the if block is emitted to the VM, we need to backpatch, as you see here. I emit up jump, then I need to backpatch, but I need to backpatch from that index. So let's back. Also I will need to emit the byte up. Okay. And then I will treat the else block. To treat the else block we need a condition. If the token match token else, we will call the statement function to handle that block. And then we need to backpatch the else offset. So as you see here guys, we have 2 pop. Why is that? So we will return to here. If the condition is false, I need also to remove that false from the stack. So I will jump here. So if the condition is true, I will continue. I will not jump. So I will continue. I need also to pop that. If I continue, that means I will only execute the if block. So I will continue this byte until I found jump. I will not go here. I will directly jump to some instruction out of the else block. So this jump is related to else block. If the condition is false, that means I need directly to jump to the else block. I don't need to jump here because this jump will offset the else block. I will jump here to treat the else block and I will continue. So let's come back and let's implement these functions, the emit jump function and also the backpatching function. So for the function emit jump, I will accept a byte, and what I need to do is to emit byte, that byte. Also I will emit 2 bytes, the jump offset. So I will do that in hexadecimal, and then I will cast it to a byte. It's 0 initialized or 1 initialized. So I will do it also here. I'll cast that to you can initialize it to whatever you want. In this example I initialize it by 0, but you can initialize whatever you want. So keep in mind that it's just an initialization. So I initialize it by 8 ones. So you can convert it to decimal and see what's the value. It's 255, I guess. So I will go and I will return the get current chunk, and I will return how much I emitted right until now, and I will subtract 2. Okay, so after that I will implement backpatching. So we need the offset, and also I will initialize a function, a variable get current chunk minus offset and -2. This, it will give us the jump number offset. So what I need to do is to test if that jump offset is greater than the maximum of 2 bytes. I will do raise an error. Too many code to jump over. Return. And finally, what I will do is to modify the current chunk, the code at the position of the first byte is the offset, and what I need to do is that jump offset, I will shift it by 8 and end with x of ff. Also, I will do the same thing for the second byte. Offset +1, and what I need to do is to do the AND operation with 0xff. So that's it. So by doing that, we will backpatch that. So let's compile. So before compiling our code, what we need to do is to jump to chunk.h and add these 2 bytes. Up jump if false, and up jump. So let's disassemble that by going to debug.c, and before of const I will do up jump if false, return. I will implement that jump instruction. I will implement this function now. Up jump if false, and I will pass to it chunk and also the offset. For case up jump, I will return the same thing, jump instruction, up jump, so let's implement that jump instruction. I will go before here, and what I need to do is end static and jump instruction, and what I need is the opcode, also as the chunk, and also as the offset. So it's 2 bytes here. Jump offset is, so I need to read, I need to do something like that. So I need to go from this byte to get the actual jump offset. So what I need to do is to use this bytewise operation. So what I need to do is cast that to an int16.8. So I will get the chunk code offset +1, and I will shift it by 8, and then I will do the operation OR on the next byte. +2, and I will copy that from here. What I need to do is to print the actual offset. So here I have the offset, and also I will need to print the next instruction. So the next instruction is the offset, the actual instruction, plus the jump offset +3. So then I will return offset +3. So that's good. So let's go to the VM to implement the jump if false, and also the jump. So first of all, I will need to add a macros that will be helpful. This macros, what it will do is to read the 2 bytes of offset and return to me the actual number that I need to add it to the IP so the VM will read the next instruction. So I think this macro is called read short. So I will increment the IP by 2 to jump over the two bytes of the jump offset. So what I need to do also will cast. I will cast the number VM IP -2, the first byte. I will shift it by 8, and then I will do OR operation on IP -1, the second byte. So let's undefine that. Undef read short. So let's interpret this 2 byte code jump if false, and what I need to do is to read the jump offset. So it's a called offset, and I will do read short, and then I will check the falsiness of it is falsy by picking the value on the stack, the first value on the stack, the top value on the stack. So if it is falsy, I will jump over by doing VM IP plus equal offset. So then I will do break. So let's implement the easiest one, case up jump. I will not check nothing, just I will increment our IP by the offset. So offset VM IP plus equal offset, and I will break. So that's it. And let's back and recompile our project. So send implicit declaration, that's what I need to do. Go to compile, compiler.c. Okay, so I will go here and I will will go from here and do a prototype of static void declaration and also static void statement, and that's it. That will solve the problem. So clear, make all. So everything is good. So let's jump to sample with end. I will remove all that and I will do a simple program. If true, I will print 1, otherwise I will print 2. So let's do and execute that. So and sample end. So as you see guys, here we have up true will auto stack true and jump if false from this instruction. If the state of the stack is false, I will jump to the instruction 11 and the instruction 11 just pop. So also you have here a jump from the instruction 8 to the instruction 15. So the instruction 15 will help to the machine. So our condition, we have true, so we have true, so this, it will not work. The VM will not execute that because the state of our stack is true, so it will continue to next extraction pop, and then it will load const 1 and then it will print that. Okay, it will print that, here you have, and then it will execute jump to jump over the else block. We don't need to execute the else block, so it will object and then it will directly skip all the instruction in the else block. This is the instruction inside the else block. It will skip it to instruction 15, and the instruction 15 is the instruction outside the else block and it halts the machine. So let's do the inverse. Double dot end, let's do false. So this, it will print true. So cat sample and I will do the same thing. So as you see, we load false, and when we load the false, the VM will execute that because the state of our stack is false, so it will directly jump to the instruction 11. So in the instruction 11, here we do a pop, then we execute the instruction inside the else block, so which printed. So guys, until now we have simple if statements, and you can do if else statement if you want. So let's do that, and let's do if else true will print true, else print true, and let's modify that and do false. So the actual program will print true. So I will create that. So get sample as end. So what I need to do, we'll execute that. As you see, it prints true. So this is the bytecode. We have a bunch of jump if false, and jump. So until now we don't have a support of something like that. So something like true and true, or if false or true. We don't have logical operations like and or. We didn't implement that yet. So let's jump to the whiteboard and talk about something, and then we will jump to the code to implement that. So what we will do right now is something called short circuit. If we have an expression that has an AND logical operator, so if the first left hand side is false, is directly false. We don't need to execute the right hand side and do and see what's the value. If the first value is false and we have and, the second thing it doesn't matter. I will load false. So the second thing, if we have true and we have and, we must execute the second one, and the value of this all logical statement is the second one. So true and something else, it could be false or true, doesn't matter. The answer, it will be based on that right hand side. So the inverse in or logical one, if we have true and or and something, directly it's true, the statement all is true. So if we have false or something, the something is the answer of this logical statement. So let's see an example here. We have if false and true. What we need to do is to load false and jump over directly to else statement. We don't waste the time and to reach the right hand side. This is called short circuit. So as you see here, we have false and jump if false, it will jump directly to the normal one jump of the if statement and else statement. As you see here, we have the normal ones, op jump false op and if block and jump and else block and so on. These ones we do it. We treat it right now. This one we have in our code. Our code it could do this, but we don't have this one. We add this one on top of treating if else statement just to short the circuit of expression. So we have false and I will directly emit another op jump false and I will do op and the next right hand side. So if false, I will not treat this side, I will directly jump to the normals one. If we have true here, I will not jump to something else. I will continue because I need to see what's the value of the right hand expression. So the same idea on or, it's like the same idea. We need to emit 2 bytes. Remember, these two things, our code can do it, our interpreter can do it, but we will add on top of it something that will optimize our logical expression. So if we have true or something else, we directly jump because we have true. We directly jump and not treat the right hand side. So we have true, I will continue and jump and read that jump and directly jump to our conditions from the start, and we'll check if true and the pop. If it is true, I will do if statement. If it's not, I will jump, and so on. So if the condition we have in the left hand side we have directly false, we need to treat the right hand side. So if we have false, I need to jump and continue. I need to jump to treat the right hand side. So yes, okay, I think I did a mistake here. If we have true, okay, the second one is false. So in this example we have true. I will directly enter to the if block. I will not reach the second side. So I have true. I will not jump till I find a jump, and then I will directly jump to something I know. So if we have false, I will jump from here to here to treat the right hand side. So that's called the short circuit. So let's jump to code and implement that. Then compiler.c. So first thing first, I will go to our rule of our array of rules. I will add 2 functions and can assign and static void or. So in the end it's a unfix operation. I will add and the precedence is and for or the precedence is or, and the handler function of that is or. So let's go to if statement, and here I will add the implementation of this one. I will add the simple one, the and. So the jump offset will be emit jump up jump if false, and then I will emit byte up. And we will continue parsing on precedence and +1 to treat. If we have a bunch of and, I will treat the left associativity. So I will backpatch to know where to jump. Backpatching on the offset. So let's implement the second one. Static void or can assign. I will emit two instructions, jump if false and also jump. I will emit jump up jump if false, and also int jump offset emit jump up jump. And then what I need to do is backpatching the jump if false offset, and then I will emit byte up. I will continue parsing, parse precedence, break or +1, and then backpatching on the next one, jump offset. So that's it for short circuit, for and or. So we did that just to shortcut the short circuit the logical operation, but the whole work is on the if statement. Also if statement, I will emit jump if false and jump. We did that just to escape the right hand side. It's just sort of an optimization. So let's recompile that and see. Make so we don't have any errors, so I clear that. So we'll go to our VM sample and I will simplify that by just doing if true and if false and true. I will print if block. First if block. So if I do true or false, it will short circuit because we have an or. we will not treat that one because we have true and or, so we'll directly do the job. And here we have false, and we'll directly skip that one. And here I will do else block. First else block, and second if block, and else print second as block. So let's execute and let's see the code. So as you see here, we have false and true. So we have false. So we'll jump up, and you see we have also true here. I will need to short circuit that. I will need to jump to the next one. So false, I will jump to the instruction 6. So we have false, and then I will continue. I have false, then I will jump over to the instruction 16 to print the first else block. So as you see here, this is the runtime execution. We have false, and I will jump to the 6. So we have 6. I will test the falsiness. I have false, then I will go to 16. I will pop, then I will load the first else block string, and then I print it. So the first one is true. I did short circuit because I didn't reach the right hand side. You see the right hand side is true. We have true on the right hand side, but I didn't reach that one. I directly jump over it because I have false on logical operation end. So the second one, I have printed the second if block, and that it's true. Also I short circuit that. I short circuit the false one because we have or, and I have true, so I need to skip the right hand side. So as you see here, where is it? Okay, I have true, and I will jump directly to 27. So I will not treat, no, I will jump to 29 here because we have true. I will skip that false one. That's the short circuit. I will skip it by the next operation, jump to 29, and then I will do the rest work for if else statement. So as you see here, I will jump if false to 39. 39 is that, and I will jump that. So good. So let's go to our common file.h and deactivate the debugging macros. So I will make clean, make all, and I will clear that. I will cut our sample, and I will run that on our sample. So as you see, we have first else block because this condition is false, so that's good. And also I have the second if block because we have the statement true, and as you see I have second if block. So guys, we've treated all things about if else statement. That's called the conditional brushing. So our language is capable of doing many things, doing printing, doing scoping, local variables, and now it's branching. So see you guys in next session to treat while statement, for statement, and so on. And so guys, we are on a stage that we are happy about our end language because we did something really good, and that's good. So let's jump, and I said let's jump. So let's see you guys in other session to treat something more goods and to treat loops. So see you guys.